Hi, I'm Matt Williams, and I am the International Trainer for the Fax and Document Distribution Group at OpenText. In this short video, I want to help you understand how to get more out of one of the tools that I always talk about with my students. That tool is Wireshark, and it's an amazingly powerful way to get a better view of what's happening on your network. We use it in class for several different purposes. We look at the different client connectivity options in FaxUtil. Sometimes we look at the bandwidth consumed by a typical fax over IP call. But the most common reason that we use Wireshark in class is to get a better idea of what a good fax over IP conversation actually looks like. It gets even better when there's something wrong on the network so that everyone can see what a problem looks like as well. When you first start up Wireshark, it can be a little bit overwhelming. Here's a capture I made with Wireshark on my test network. Although I really only care about one fax over IP conversation, I'm having to sift through all this web traffic as well. If I go to statistics then endpoints, I can see that my gateway and fax server aren't the only devices being watched. In this list, I see some virtual machines running WriteFax, a few gateways, and my VMware server host machine with its 2 NICs, and more. Imagine if this were a real network, not just my little test network. This list could end up being a lot longer. Now, I could just scroll through this list to find the packets that I really care about, but I still have to look at a lot of non-relevant packets mixed in with them. An easy way to clean this up a bit is to use display filters. That's what that little text box is for at the top of my Wireshark window. The 2 endpoints I care about are 10.9.5.1 and 10.9.5.254. So I'll enter a filter to show packets for the first one. That filter is ip.addr equals 10.9.5.1. That's going to show me any packets that have my fax server as a source or destination address. I can add the second address after 2 ampersands to make sure I only see packets going between these 2 devices. Adding an exclamation point and syslog wipes out those packets. I do the same with TCP port 80 to eliminate web traffic. Each time I update my display filter, it has to parse through all the packets captured to figure out which stay in the list. Right now, I only have to sift through about 10,000 packets, which doesn't take very long. But in the first couple of versions of this video, I had about 95,000 and then 45,000 packets. On my underpowered machine with only about 300 megs RAM, Wireshark crashed under the load of filtering my view. Although display filters are useful, they are more effective and much more responsive if we limit the packets captured to a much smaller set. To do this, we use capture filters, which, as you can probably guess, limit what gets captured. I'll start a new capture by clicking on the top left icon. Clicking on Options for the NIC that I care about allows me to enter a good capture filter. Now, the syntax is different, but worth learning and not too difficult. Host 10.9.5.1 and host 10.9.5.254. Clicking on Start tells Wireshark to ignore packets going to or from any machine other than the ones I just specified. Continue without saving gets rid of what was in the screen before without saving it for later. My display filter is still there, so I click on Clear to show me everything. But turns out there's still a lot of web traffic that's being captured, as well as syslog traffic, so I can create a simple display filter for that. I'll let it continue until I see the fax over IP call finish, and then I'll enter a good display filter. Exclamation point tcp.port equals 80 gets rid of all that web stuff. Exclamation point syslog gets rid of syslog debug traffic. Finally, exclamation point ICMP to get rid of all of that too. An initial capture of only 2,600 packets is far easier to deal with on lowly machines like this. So let's review my filters. I showed 2 types of filters. The first was a display filter. IP.addr ADDR equals and then an IP address restricts the display to packets to and from one machine. Filters are case sensitive, but the text box is green when you get it right. To do a logical AND, use 2 ampersands between the clauses. Use 2 pipes for a logical OR. Although you might want to use something like this to say not equal to, it's not going to work. Instead, you need to put the exclamation point at the beginning of that clause. Unfortunately, the version of Wireshark that I'm using doesn't have good documentation for filters and what keywords to use, so click the expression button for a list of all the keywords. Capture filters limit the initial capture and use a very different syntax. To limit to a single IP address, use host, then the IP address. Logical ANDs are separated by the word and logical ORs are separated by the word OR. To get rid of web traffic, I can say port not, and then its port number. Click on the Capture Filter button in the Options dialog for a list of sample filters. I am Matt Williams, and I am the International Trainer for the Fax and Document Distribution Group at OpenText. I hope you found this video useful. For more information, visit us at faxsolutions.opentext.com. Also, check out faxlearning.wordpress.com. And to suggest another idea for a video just like this, contact me on Twitter, where I go by the name Technoevangelist. Thanks so much for watching. Goodbye.